So, firstly, hi everyone. Welcome to today's webinar. My name is Kurt Martinison. I'm the solutions leader here at Nuaware, and I'll be your host for this great session that we have planned today with GitGuardian. So, GitGuardian is at the forefront of securing software development by protecting secrets, code, and infrastructure in real time. Today, we're exploring the end-to-end secret security, such as protecting code, productivity tools, and environments. Before we dive in, let me just do some quick bit of housekeeping. The webinar will last about an hour, around there. There will be a Q&A Q&A at the end. Please do drop your questions in the chat, or there is a Q&A box. If you have any, I'll pile them all up and I'll address them at the end. The webinar is recorded, so anything that comes out of this, it is also posted on. So if anybody's interested in taking a look later, we can send you the YouTube link. I think that's pretty much it. So without further ado, I'm just going to introduce our speakers today. So from GitGuardian, we've got Lynn Lopez, the Global Channel Alliance sales leader, as well as Daniel Welsh, the solutions lead. Over to you guys, and thank you very much for being here today.
Thanks, Kurt. I'm really excited to be launching our partner program in EMEA. I'll let Daniel talk about the solutions, and I'll come in at the end and give you a little bit more details on our partner program.
All right. Appreciate the introduction, Kurt, and also obviously for you setting all this up and organizing it. Without too much further ado, let's get into it. So starting out with just this obligatory slide about the company, who we are, GitGuardian. I think what's relevant to you here possibly is that we are a French company, but we have headquarters in Paris as well as in Boston, and we have reps as far as California and the United States. So we have global coverage for our client base. And as you can see here, our client base currently is 600,000, a little bit more than that, developers worldwide. And we always like to mention we are the #1 most popular, most downloaded security app on the GitHub marketplace. So getting to what we actually do, it's a fairly simple problem, and there's a metaphor that we like to use to explain really the challenges that we're addressing here. So if you think about real life, in your life, what you're doing, you would never think to just leave the keys in your front door and leave them there for anyone to access and be able to open. It's a no-brainer. The problem is that in software engineering, this is something that happens every day. Software developers are constantly leaving keys to the company's front door in code that then allows malicious actors access to what they're after, within internal environments. So I do want to underline that this is not anything malicious. It's simply human error. This is a byproduct of modern software development practices, of having keys left in code for testing purposes, a lot of different moving parts, not paying attention. So software engineers are overwhelmed with too many things to focus on at once. And unfortunately, this is one simple human error that we find occurring a lot, but it is the equivalent of leaving the keys to your client's front door open for anyone to access. So before I get into how we go about detecting secrets in code, I want to make sure we're all on the same page, what I'm talking about when I say a secret. So a secret is really a broad category. It's anything that allows remote services to authenticate and communicate with each other in an automated fashion. So it could be API keys, certificates, username and password, connection strings, assignment strings, really anything that lets two things talk. And the reason this is so important is that modern software development is essentially patching together a bunch of different services to talk to each other, share data, exchange things, and then you have the higher functionality that comes out on the other end. So the more that you have these different moving parts that are talking, and they're all automated and not actually human controlled, secrets are really the oil that lets this engine run. So if you have access to a secret, you have access to the data or service behind it, and that secret gives access to its communications and everything it's doing. And that's why it is essentially the key in the door to your client's data, services, all the sensitive information that they're trying to keep out of the hands of malicious actors. And what we're seeing is secrets are increasingly privileged in attacks by malicious actors. Part of the reason is, like I just said, secrets are used very frequently and increasingly so as modern software development takes this sort of microservices architecture approach, but also because as we get collectively better at addressing runtime vulnerabilities, we have SAST and DAST scanning, we have good sound patching practices, it's getting more and more difficult for attackers to carry out technical exploits by, attacking a vulnerability in software. So as we get better at one kind of defense, reactors are going to change tactics and adapt. So if they find a secret that gives them access to the data they're after in the first place, they don't need to worry about finding a vulnerability or finding an unpatched version of software. They can just grab that secret, unlock, and open the door without any further ado. So as you can see here, there's quite a few very high-level breaches that have occurred using secrets. The most recent one that's not on here was the US Treasury breach that happened, I think, a few weeks ago at this point, also involved secrets that were left around. So this is definitely a privileged vector of attack by threat actors. You can see here over 80% of attacks in 2024 involved compromised secrets on some level. So even as companies are setting out different code security programs, different AppSec stuff like SAST and DAST, secrets are another thing that usually doesn't fall in those categories and is becoming increasingly important in a robust defense program. So the way GitGuardian has set out to address this challenge is we have essentially 3 product lines that are looking at where secrets fall within your client's environment, as well as how attackers are going to potentially access and exploit those. So the first thing we have is what you see here in the middle is public monitoring. This is looking for secrets that are leaked by a company's developers on public-facing GitHub, as well as on Postman. GitHub is the #1 code sharing platform. Basically, every software developer in the world probably has a GitHub account at this point. This is where they're sharing code, whether it's for work, side projects, education, open source things. It's really where the world's collaborating on group projects on software. So it's very common to see developers accidentally leaking company-related code with company secrets onto public GitHub. And so that's why we focus our monitoring for the public perimeter on GitHub. This is outside the control and typically outside the visibility of companies' security teams. The next thing that we have is on the left side of the screen, secrets detection. This is internal. So the public side is external. That's somewhat reactive, catching secrets that are already out in the wild. The internal side is focused on finding secrets that developers have left around the internal environment, primarily source code, but also development collaboration tools. Anywhere devs are sharing information, they're liable to be sharing secrets. So we aim at scanning a company's entire internal environment, finding where secrets are not being handled correctly, giving security teams and development teams the means to efficiently remediate those incidents at scale where secrets are already found. And maybe most importantly, giving developers the tools to catch when they accidentally put secrets in code and stop them from leaking to begin with without diverting them from their main development work and without having an additional context switch, essentially helping them stop this problem while remaining in the main flow of what they're doing. And then the final product line that we have, you see on the right, is what we call Honey Token. It's essentially bridging the two. So what we do is create secrets, and we intentionally put those throughout the code base, throughout internal environments. And they're real secrets in the sense that they do work. You can call the secret and call the API and see something's happening there, but they don't give access to anything. So the idea is that by planting these around an environment and then monitoring them, we can catch when either a threat actor potentially has access to internal networks because they're sniffing around internally and we see it's an internal IP address accessing these secrets, or detect potential code leaks. If we see it's a public IP address, that means whatever code that Honey Token was placed in has been leaked on the public internet somewhere. So that also helps us catch potential data breaches, sensitive data loss, things like that, and essentially proactively catching when these things happen and then allowing you to remediate the situation internally before something worse happens. So those are the 3 product lines, and what unites them is this one philosophy that you see shared here on the screen. It's essentially end-to-end focus on detection, remediation, and prevention. Those are the key building blocks to an effective secret scanning solution. So the first piece is detection. This is super important. Obviously, we have to be able to catch secrets and be sure we're not catching anything else, but also that we're not missing any secrets. So we have a full-time team of people whose entire job is to build, develop, and refine this detection engine. We have been stalking every commit to public GitHub going back to 2017. So that's essentially our training set. It's several billion commits of code at this point. So we have a very, very robust engine that has a very low false positive rate, but also does not miss many secrets. So it's called a high recall. We catch as many as possible. Altogether, we have about 500 different types of secrets that we can detect, as well as the ability to create custom detection patterns yourself, as well as exclusion patterns to leave things aside we don't want to catch. And what's really interesting here is we can also, for some of these, do a validity check. So essentially check the exploitability, see if a secret's still valid. If so, that needs to be remediated immediately, and it helps save your client security team's time. I'll get back to that here in a second. And then the next key piece here for detection is where exactly we're going about scanning for secrets. So there's been a big emphasis in everything I've said so far on source code. So as I said, public GitHub and Postman outside your client's perimeter. Internally, it's going to be essentially any sort of Git-based source code management that any company is using today. GitHub, GitLab, Bitbucket is your repos. So that's where we find most secrets, and that's definitely the focus, but there's going to be secrets other places where devs are sharing information, collaborating. So we also have scanning capacities in ticketing systems, documentation systems, messaging platforms, cloud drives, container registries. We have a more comprehensive chart that I'll show you here later on. But the idea is we're trying to catch anywhere in an enterprise environment, software engineers are going to be sharing information, collaborating, potentially using secrets to do so. So that's the first piece. That's how we're going about finding the secrets that are exposed. Once that's done, you have to know what to do with it. The so what is detection without remediation processes and workflows in place is simply noise. If you just have a CSV of 10,000 secrets that are found, that helps no one. That's going to be a bottleneck. It's a bunch of unplanned work and it makes the problem potentially worse. So we've developed a platform to focus on decentralizing and distributing the remediation process in order to avoid this bottleneck. We found that up until this point, very often security teams, the ones that are doing something for secrets, are going to be focusing on this. And usually we would have a handful of security professionals who are responsible for securing hundreds, potentially thousands of developers. And they have to handle all the other security tasks that come in on a daily basis, as well as unplanned stuff when attacks and compromises happen and things like that. So for one individual to be able to handle hundreds or thousands of secrets from a full development team, it simply doesn't scale. They're not going to get ahead of it. And secrets are going to keep building up in the code base over time while they're trying to get rid of them. They're essentially in a boat with a hole in the bottom, trying to bail water out, and the water just keeps coming back in. So we found the only way to really head this off effectively is to include the developers in the process so that the individuals who are exposing those secrets are also included or perhaps even responsible for the remediation process, allowing security to oversee that, but allowing development teams themselves to be able to take care of this, to do it proactively, and to have prevention tools that stop that from happening in the first place. This includes, developers in the security conversation and the process. They have some buy-in here. They have skin in the game. And it also bypasses that huge bottleneck that is the main challenge around secrets in an enterprise environment today. And then we have some automations and some integrations with security managers and other tools in the environment that help facilitate that process, make it a lot more efficient. I'll give you a look at what that looks like concretely here in a bit. But then finally, the last piece comes in, which is preventing. So we want to shift detection as far left in the development lifecycle as possible so that there's no incident, there's no follow-up that needs to be done. Once that secret hits the shared environments where all of your clients' teams are collaborating, everyone's going to be pulling down that code. That secret's going to spread virally throughout the organization. At that point, you're never going to get rid of it. You just have to revoke and rotate it, but that's going to potentially break applications. It's going to create additional dev work, further coordination. It's just a big mess and it creates a headache for everyone. It's a further friction point to dealing with this issue. So we provide tooling to allow developers to catch those secrets on their local workstation before it leaves to a shared environment, using the tools that developers are already using. So whether it's a CLI command tool in the terminal or in the IDE that they're using, we give them the means to catch those secrets, help correct the problem, help reinforce good security, good secrets hygiene rather, not putting it in code, and give them the means to prevent that additional unplanned work while avoiding the security risk spreading throughout the environment. So that's our approach. That is the best way to eliminate this problem at scale in an enterprise environment. These are the key building blocks for any effective secret scanning program. Before I get into the next parts about who we're typically working with, who is most in need of this kind of a solution in our experience, I just wanted to drop in and check with Kurt. Do we have any questions or anything that's come up?
No, I don't think yet. Give me 2 seconds, but just on that, guys, if anybody does have any questions, just please pop it in the chat. I also do have, if you don't want to put it in the chat, you can message me directly or pop it in the Q&A box. But cheers, Daniel.
So this next section, we're really going to focus on our existing client base and where in your client base there's probably a good need for this and where it can really help you better support them and make their security program more effective and more efficient. So I would say two things stand out to me here most. One is the type of company and two is the way their development's organized. So in terms of type of company, as you can see here, we have good traction and good need in most of our client base today are software development firms. Obviously, they're producing a ton of software, so they're going to have a bigger need for this kind of a thing because there's going to be more secrets around. But in addition to that, we also have anyone with extensive internal IT infrastructure that is being home built, homegrown, homemade, with a lot of moving pieces, communications as well as those with sensitive data concerns. So one of the ones that stands out to us a lot are telcos, as well as financial institutions, financial services, also anything around healthcare and pharma, those companies that are dealing with sensitive individual data, PII, health information, and stuff like that. They have significant data security concerns that one secret leak could compromise all of their patients or their users' personal information. And that's a huge reputational risk, regulatory risk. It's a strategic level risk for the business. So this is very, very critical for them. And then insurance and oil and gas and things with a lot of worldwide, I don't want to say sprawling IT infrastructure, but really bits and pieces all over the place that are communicating nonstop, that have these services that are talking to each other and using secrets to do so. So those are the types of companies that typically have the greatest need around something for secrets in place. And then in terms of the development teams, obviously, the more developers there are, the higher the risk becomes because, again, this is a human error we're correcting for. And every developer has a certain amount of, let's say, just existing risk of leaving a secret in code. So the more developers you have, one, the more complex projects and the more collaboration they're doing. So there's probably more secrets involved. But just by dint of having more individuals working on a team, each individual has a certain element of risk that they introduce. So larger developer teams are going to naturally have bigger risk around secrets being leaked, but also much more complex remediation process. And they need these enterprise remediation workflows and the decentralization distribution of those remediation workflows, because once you have several thousand developers working together, they can't all be waiting on a couple of people on the security team to handle something, or if a secret's revoked and rotated, the application breaks and suddenly thousands of people are, what's going on? It's not a good day for anyone. So large developer bases, as well as these different industries, are really where we see those companies that have the biggest need around something for secrets in place and the biggest need for that robust 3 points approach that I mentioned before. Now, that being said, we have a wide range of clients and customers. I think our smallest one is 5 developers. Our largest one is around 20,000 developers. So this is by no means limited to what I'm saying here. But if you think about your existing client base and the companies that you're supporting, anyone who fits in that rough bracket probably is a need for something around this, and we probably could help them improve their security coverage and be a little bit more efficient in doing so. Lynn, anything you want to add here?
I was just going to say the same thing, that we have some outliers that are smaller organizations that are more mature, and recognize that in order, as they are more mature with security in general, that secrets is a component of that. And we scale all the way up into tens of thousands of devs. So a good fit would be, understanding if they're doing development and if development is core to their business, or if they're in a highly regulated space, right? I think those are 2 really easy questions to ask yourself. Is this a good fit? In a couple slides later, we'll talk about some of our tech alliances, which will also help you identify some potential good fits as well. So stay tuned.
So shifting from the actual companies and organizations you're supporting to the teams and individuals that you're supporting and who we're typically working with, we find there's a rough split into 2 branches that mirrors our product line. So for the internal monitoring, the internal secrets and securing all the internal environment, there's a wide range of different teams. It's really anyone who has stakes in securing the software development process. So sometimes it's AppSec, product security, platform security, security engineering. Very often it's going to be DevOps teams, security architecture people, cloud security teams. Sometimes it's those teams who are responsible for providing all the developer tooling. So anyone who's working on CI/CD pipelines, source code management, container registries, and platforms for that. Wide different variety of personas and teams we're working with. It's just going to depend on the company by company basis. But if you just think, is this team I talk to, are they supporting software development and providing security and efficiency to software development? If so, it's probably something they're going to be interested in. For the public monitoring, it's a bit different because we're catching secrets or potentially code, sensitive internal information that's been leaked out in the public domain. So this is a real serious security incident, and we're typically going to be working with teams that are addressing security incidents in sort of a response fashion. So sometimes it's SOC teams, threat detection teams, threat intelligence, CERTs, incident response teams, anyone who's dealing with that sort of external leakage, data loss prevention teams. And then finally, we sometimes also work with red teaming, and people are looking to establish, improve security posture for a company from an outside perspective. So we've had some companies that have their red teams use our tool to conduct, offensive security assessments of their own company to see what the secrets that are already out there could potentially be used to expose. So that's for the public piece, and then the honey token, like I mentioned, it kind of bridges between the two. We've seen users on both sides that are interesting. It's a sort of unique new entry to this space where there's not really anything else around like it. And both of these different personas I'm showing here have found value in use cases for implementing that kind of a thing. So looking to the wider space, where do we fit in amongst other tools that already exist within your client's tooling ecosystem? We find for secrets detection, there are essentially three broad categories. And usually we find companies start out with the leftmost one here, which are open source solutions. So there's a number of free open source tooling for secret scanning. The most common ones are Trufflehog, GitLeaks, and Yelp Detect Secrets. There's some others out there, and there's a lot of companies that even work on building their own or building their own on top of those existing solutions that I mentioned. The thing is that these, because they're open source tools, you get what you pay for in a certain sense. So it's a good starting place. You can catch some secrets for sure, and it definitely awakens teams to the concern around secrets. Usually someone who scans for the first time is shocked by how many they find. So the problem is the detection engines haven't been refined and trained against a large training set of commits. And they also don't have dedicated teams who are doing justice. So they tend to be quite noisy. They definitely don't catch all the different kinds of secrets that are out there. They're going to catch a lot of things that aren't secrets. And to the extent that you can play around with the settings, a lot of users are going to exclude a lot of things to avoid the noise. But that also means they're missing secrets, and that's going to be risk that's not controlled for, but it could potentially lead to compromise down the road. So that's the first challenge. And the other is that it really is just a dumb CSV output of here's 1,000 lines of secrets we found. Good luck. It doesn't give any context around what could that give access to? What's the repo this is in? Is this valid? Who's going to be impacted if I change this? You don't have any idea. You just have a list of secrets, and then it's on the security team typically to go and do the footwork and investigate each individual one, which in our experience can take on an average of around 2 hours per secret. So if you have thousands of secrets for the average company, multiply that by 2 per secret, it's simply not sustainable. So it's a good check in the box. It's a good eye opener to the problem of secrets, but it's not adequate for a large, serious enterprise development organization. So that leaves the other two options that you see here. One is the development platform native security solutions. So for GitHub, you have GitHub's advanced security. For GitLab, you have GitLab Ultimate. Both of those include some component of secrets detection, as well as several other security tools. So these are kind of presented as a Swiss Army knife, does all your different main code and application security functions all together at once. The problem is that, for one, they're limited to the platform they're native to. So increasingly, I talk to companies that are using GitHub and GitLab and Azure and sometimes Bitbucket. So if you're using GitHub's solution there, your GitLab repos are going to be completely uncovered. And any of the developer collaboration stuff I mentioned before, Slack, Jira, Confluence, Teams, container registries, those aren't included at all. So you'll never catch any secrets that are in there. So you have a very limited space of coverage that is not going to correspond to the entire enterprise perimeter of developer collaboration tools and in the environments that you're going to encounter. And then these are dev tools, essentially. Now, like I said, we believe that empowering developers to remediate this problem is key, but you have to have a blend of a security-oriented approach in developer enablement. So these are things that are designed to include some checks for vulnerabilities and include them in standard development workflows, but secrets aren't really like the rest of development workflows, and there's a lack of contextualization and understanding what's going on and be able to track the progress of these different things from in a centralized fashion by security teams. So we find that that quickly becomes a bottleneck and a blocking point for really getting ahead of this problem and stopping it from spreading, eventually eliminating it over time. You have some coverage, you have some scanning that's going on, and it's designed to go in line with your developers' workflows, but it's not going to give a rich context that allows this to be handled efficiently, and it's not going to allow the entire process and progress of dealing with this over time to be monitored, tweaked, and improved to be as efficient with this and eliminate as many secrets as possible. So then the last solution is where we come in, a best of breed solution that is designed for just secrets detection, doing this one thing very well, going very deep with it, scanning everywhere, having workflows that are designed to facilitate secrets remediation and nothing else. It's not a generic workflow that you kind of cram secrets into. Everything is designed just for the processes around secrets. And then implementing those three building blocks that I mentioned earlier of an effective secret scanning solution. So this comes to something we hear very often. There's a lot of different code security tools out there, and each of them obviously has to have their own acronym. There's a lot of jargon and buzzwords floating around, and a lot of time, it's hard to identify what exactly your clients are covered with. If you have all these different tools out there, some stuff that your clients already had, some legacy stuff, it's hard to identify the overlap where sometimes they have doubled up coverage, and other times where maybe they have gaps in coverage. So one question we hear a lot is, why are the things you see here, SAST, SCA, and CSPM, not good enough for secrets? Sometimes even a SAST tool does some limited level of secrets detection. And really what it comes down to, I would say that the common, I'm not just going to read the slide to you, but the common denominator here is that secrets is a different kind of vulnerability. It's not a runtime vulnerability. Something like SAST, we're looking at how the code's functioning, and you're really trying to identify some kind of a flaw that can be exploited when that program is in operation in production. Secrets aren't something that you're attacking. It's the code itself is the attack surface. The code itself is the vulnerability. It's not the way the code's structured. It's having the code, just the text of the code with the secret in it. So the processes and the focus in the way that these other tools operate work very well for their context, but it just doesn't apply to secrets because it's such a unique situation with its own needs and its own problems. It requires a dedicated solution to handle effectively. And trying to do it with one of these other tools that you see mentioned here is maybe going to address it a little bit, but at the end of the day, it's not what you need to really take care of the problem and do it effectively and efficiently at scale.
We had a customer say there are other testing tools out there. It's okay to be good enough, but with secrets, all you need is one secret that could be exploited that lets someone come in undetected into your network. And that resonated with me, right? From a non-technical scenario, you need all three of these pillars, much like a stool, that in order to be fully protected, and you've got to it can't be check the box. It can't be good enough. You've got to have a thorough approach to secrets, because it only takes one for a bad actor to come into your environment undetected, and then they can move laterally and do all kinds of damage. So that in and of itself is kind of the big differentiation, is that secrets as good as and as thoroughly and now fully enterprise capable as what GitGuardian has been doing.
Before we get into this next section, just want to check in with you again, Kurt.
Yeah, we've got a few questions. Would you want to take them now, or do you want to wait till the end?
I say we go ahead and take them now. That way it's relevant to what we're just discussing, and it's not something out of context in half an hour.
Okay, so one key one, and I think this might be kind of on that SaaS, literally the slide that you've just presented. I think maybe diving into that a little bit more. So what is basically what is not covered under SAST? I think they've got SAST already. Why do I need GitGuardian? I think that's the question in here. How I'm reading it.
There's a few elements here. One is the way that you go about picking out the secrets. So SAST is usually based on just regex pattern recognition. So one, you have to have a known library of patterns that you're searching for. And if
Mhm.
your team, like the security vendor, if your development team is not focused entirely on developing the most robust secret solution possible, this is just one sub-team of the wider SaaS solution. Having all those patterns in that library, constantly updated and constantly having the new, most commonly used secrets, that's a challenge for one. But an even bigger challenge is a lot of secrets are not going to be able to be picked out using this known pattern. So there's high entropy strings in code, just random long strings of 50, 100 letters and numbers mixed together that are very often used as secrets. And you can't find that with a known pattern. This is a little bit under probably half of all secrets that we find. It depends more on what environment you're working in. If you have a lot of internal services that are being home built, they're going to typically be using those kinds of secrets. So you have to have a dedicated engine that is designed to pick out those kinds of high entropy strings, but have the contextual like knowledge looking at the surrounding code and being able to determine, is this being used as a secret or is it just a high entropy string? Because there's a lot of times you have high entropy strings in code that are being used for other things that aren't secrets. So if you don't have that baked in, then you can pull out entropy, but you're going to have hundreds of false positives and noise and alerts, and everyone's going to be tired of it. So
Mhm.
that's part of it, is having really a tuned engine for detecting just secrets and having that be one of your core competencies of the provider, being able to do that. SAST isn't going to have that. And then another thing too is SAST is typically, because the focus is really looking at runtime vulnerabilities. Yes, secrets are included because it's in the code, but typically we're looking at the code itself and how it's functioning. They focus on language and they're language specific. We're language agnostic, so we can detect secrets anywhere that secrets are found in plain text, not binaries. But for SaaS, that's not the case, and they typically have a too narrow focus to be able to catch these as widely as possible. And then finally, SaaS, again, we're looking at code scanning. So if the developer is leaving secrets in Jira, in Confluence, in a container
Mhm.
image, in Slack or Teams, it's going to go completely uncaught.
Mhm. Do you want another question, or do you want to wait? Do you want to keep going?
I think we can move ahead and then we can
Yeah.
grab a
Yeah,
question.
we've still got the Q&A at the end as well. So if anybody does have any more questions, just pop them in the chat. I've got a couple lined up now already. Thanks, Jack. Thanks, Jack, for that.
All right. So technology integrations and where we fit into your client's wider ecosystem, and also some of the other vendors that you might already be implementing in your client environments. The first one went too fast. First one I wanted to mention is Sneak. So we work very closely with Sneak because Sneak does the other elements of code security beyond secrets very, very well. We do secrets very, very well. It's peanut butter and jelly, perfect combination. We work great together. So we do a lot of work together, and a lot of our users are implementing both tools together. And what's also more interesting is that Sneak's ASPM integrates with GitGuardian's alerts and detections. So I'm sure you've all heard from your clients many times, I want a single pane of glass. I want everything in one spot. I don't want to have to switch between different vendor dashboards. Sneak can ingest GitGuardian's detections and incidents. That can be displayed in Sneak's ASPM dashboard, and they can view and review the different detections and incidents that way before going on to the remediation process. So that's a very nice way to consolidate everything together into a single code security tool, covering all the different needs for code security as robustly and as in-depth as possible. Beyond Sneak, we have integrations with all of the main secrets managers, including but not limited to HashiCorp Vault. And this is pretty key to what we do, because if you think about a secret, there's going to be a life cycle of the secret being produced, the secret being provisioned and shared, and hopefully in a secure fashion, which is where the managers come in. And then eventually it's going to be decommissioned at some point. And that's the intended life cycle of the secret. But what we're doing is catching where that's not happening, where a secret is being placed outside of these secure handling channels where developers are not handling secrets correctly. So they're essentially two sides of the same coin. For a secure end-to-end secrets management process, you have to have a tool to manage and share those secrets correctly and provision and deprovision them securely. But you have to have guardrails in place to catch when that process is not being followed. So it's really a natural pairing. What we're doing, we're catching when it's not being followed, with the solution used to manage the secrets. And there's really 3 points of contact here where we facilitate the security guardrails and the visibility, as well as that remediation process, which is really key. Making that as efficient and streamlined as possible is going to be the determinant factor in a successful secrets detection program. So we can, by integrating with a secrets manager, we can see all of the different secrets that are being stored. That allows us to potentially catch secrets that have been leaked somewhere, especially in the public domain, but isn't necessarily attributed to a company. And I'll show you the public monitoring dashboard and what that looks like. It might make more sense here in a minute. But by having access to all the secrets that are managed in Vault, for example, we can see if the hash of a secret, so like the fingerprint of it, has been leaked somewhere publicly. Even if we don't find it in the internal code of a company, we can see, hey, this has been compromised at some point. So knowing everything we're looking for makes it much easier to find those leaks, because we're not looking for all secrets and then trying to tie it back to a company. We have this limited set of secrets and we're looking for anywhere those have been exposed. That's the first point. Then in the prioritization process of how we need to remediate the secrets, if we find 1,000, we have to figure out where we want to start. If we have access to the vault, we can see the permissions a secret has. We can see how many people are using it, how old it is, where it's present, where it's being used. So those are really key inputs to determining the risk profile of a secret, and the riskiest ones that need to be revoked and rotated as quickly as possible. So that really helps drive the remediation process and help security focus on what matters most in the least time possible. And then finally, for that remediation process, because we're already talking to the vault, if we find a secret in internal code or in Jira or in Slack or something like that, we can call back to the vault and just flag that secret, say, hey, this has been leaked. So we need to kick off a remediation process, and whoever's handling the vault can do that. But that lets us cut out an entire step of security having to confirm this and then reach out to ops or SRE or IAM, whoever's managing the vault. We can just automate that, notifying them this secret was leaked, commence the rotation process. And that also helps cut down on the time and the effort going into fixing this problem, as well as closing the risk window, the period during which that secret is exposed. And then finally, this is the current state of things as well as our planned development for 2025. So as I mentioned, where we've started and our traditional focus has been on source code management, so GitHub, GitLab, Azure DevOps, and Bitbucket. But we are expanding into the wider DevOps ecosystem and developer collaboration tools. So as you can see, we have a lot of coverage in pipelines, and container registries is something we're currently actively putting a lot of priority on right now. Anything with a star is something that's actively being developed. Those things without a star are integrations where we currently have capability to scan. So to be clear, these are all things where we are scanning for secrets that are leaked. This is where we're catching secrets. And then we have other ones that I'm not going into here about where we can share those incidents. So the idea is to really comprehensively cover anywhere developers are collaborating, where these processes and automations are taking place, and where information is being shared, and catch where secrets are potentially being leaked. So the next step would be giving you a look at what the tool actually looks like in action. Anything else to add from the others before I get into that?
Nothing from me. Anything from you, Lynn?
I think we're good.
Perfect. So I'm going to keep this real quick and dirty, to be honest. I'm not going to get into all of the features and the tags and the functionalities, as cool as it is and as much as I love to talk about it. I'm going to focus on the high level stuff of understanding the impact this has for your clients, how this can support them, and why it would be interesting to give them a closer look. So I'm going to start by looking at the public monitoring tool. Again, there's the internal environment scanning tool, the public monitoring tool. These are separate tools, separate platforms, separate interfaces. They're similar, as you'll see, but because of the needs, they're a little different. So for the public side, the way we go about this is we're looking for your developers or your company's developers, those you're supporting. We're looking for their GitHub accounts because that's where they're leaking secrets. So the way we do that is we start out with some email domains. Now, these are dummy ones for the demo, but we would put your client's email domains in here. And we simply look for any GitHub account that has ever published code publicly. When you do these commits and publish code, you sign it with an email. If they've signed a commit with your company that you're supporting's email address, then they're included in the perimeter, and we're going to scan all of their activity. So essentially what we're doing is we pull these email domains, and then we'd have a list of developers who are publishing code publicly using an email address tied to those email domains. So obviously this is a demo, this isn't a real thing, but in a real environment, you would see a list of all the different developers, the email domains that are included here, You can filter and confirm that these are all developers who should be included. They're real developers. Be sure that's a good list. And then based on this, we then give you a look at how many secrets have been found across public GitHub, how many of those developers are involved, as well as a lot of contextual information, giving an idea of what's been leaked, where it was found, is it valid or not? Is it still on public GitHub? A lot of times developers leak something, realize they made a mistake, and they'll delete it. If it's been in the public domain at some point, it's probably at risk. We've done experiments and found intentionally leaking a secret, it gets accessed by bad actors within 60 to 90 seconds on average. So it's important to know what was leaked, so we have the ability to show something that was leaked and then deleted after the fact. But really what's key here is what's been found, as well as the individual who made that commit. So you have the name, their email address, and the GitHub account in question. So the idea is that a security team would be able to set this up for, and again, this is typically going to be SOC, red teaming, incident response, someone really focused on incidents and things that are out in the public domain. They would set this up for themselves. This is designed to be a security team tool. So they're going to be able to review quickly the secret that was leaked and what's going on, see the repository that it was leaked in, go on GitHub, do their investigation. What's really key is this developer. We think that only the developer has the context of why the secret's in the code, what risk it produces. You can't really make a determination what needs to be done without contacting this person. So we've designed this to allow security teams to quickly and efficiently reach out to the developer in question, such that they can generate a incident share page showing the detection information for this specific leak. This is accessible to anyone who has this leak, so you don't have to onboard the developer to the platform for them to be able to see it. And more importantly, you have the ability to send this feedback form. So the developer can just quickly say, okay, yeah, you know what, this is a real credential. It's not personal. It does give direct access, and then some information about the incident. They would submit this feedback, and then that would get pushed back to the dashboard. So if you think about security teams' processes, the investigation piece is super important. And this cuts out an entire piece of the investigation piece. They no longer have to hunt down the individual in question, reach out to them, figure out the information, ask them the questions, get the feedback. They can just automate the creation of this link, send it to them, and have that information provided to them directly on the dashboard. What I showed you is manual creation, but we also have the ability to set up a template at an email, have that automatically go out. We can also send alerts to these individuals via other means through internal communication channels. So the idea is, as much as possible, we're going to try to automate the classification of secrets with some of those pieces of information I mentioned. So, you know, if it's still on GitHub, the kind of secret, if it's still valid, stuff like that. So tell security, hey, this 20% of secrets, they're really high risk. You should focus on these first, and then automate the outreach to the developers. So send them this information, have the developers bring security the context and information about this. And then from here, all security really has to do is review the feedback, determine the secrets that need to be revoked and rotated. Sometimes you have to have, you know, maybe log files, see what's been accessed, whatever incident response and cleanup needs to be done. And then they could go ahead and close out, resolve the incident, and specify why exactly it's been closed out. Maybe they made a DMCA takedown request to have GitHub delete a repository. Maybe the developer did it themselves. They rotated it. They can specify the reasons. So then they have an internal audit log of the entire exchange of information from detection to developer feedback to the remediation process that has taken place. And all this is done with a focus on trying to cut down that time to remediation for the security team as much as possible by removing the manual steps and having them do that outreach to the developer in an automated fashion. So that, in a very, very high level nutshell, is the internal monitoring piece. I didn't even get a chance to go into, like I said, we have the ability to detect on Postman. We can do keyword-based detections as well. So something like internal code leaks, that's another use case here where we can find internal URIs, project names, endpoints, things like that. So that lets us catch internal code leaks that maybe there's no secrets present, but it's sensitive proprietary internal code that would also allow an attacker to map out your internal infrastructure and facilitate an attack down the road. You don't want that out there, so we can help you find that with keywords as well. Any questions there on the quick 1-minute overview of the public detection piece?
No, no, I think we're all good on that. I think I've got a couple of questions, but I think what I'll do is I'll save that to the end. I don't want to break your flow, Daniel.
Okay, all good.
You're in the zone, man.
So I'm going to shift now to the internal monitoring tool, which, as you can see, is very similar, but still quite a bit different. And especially the processes here are going to be different because, again, we're scanning internal code And rather than incident response for stuff that's been leaked externally, we want to focus here on helping developers remove the secrets that have been exposed, identify what needs to be done to correct that situation, and handle it as efficiently as possible. So what you would do is set this up, or your client rather, would set this up with all their source code management, all those other integrations I just showed. Anywhere that secrets are found, they're going to be consolidated on this dash. A lot of the information here is going to be the same things that I mentioned. What is interesting is we can also, there's a connection between the two. We can see internally leaked secrets that are in our database of secrets on public GitHub. So it kind of touches back on the first piece I mentioned. This is mostly useful input of, if it's in the public domain, you want to revoke and rotate that immediately. But that's one of the inputs we have here. And again, the same automations, we want to assign a severity level based on the different contextual pieces, type of secret, if it's exposed default branch. But the difference here, the key difference is that this is really a developer facilitation tool, even if security is overseeing it. So what we want to do is we would onboard developers en masse with SSO into a restricted role. So we have an RBAC system with user roles as well as groups and groups access. So by default, an individual developer can only see secrets and commits that they have made, or in repositories that they've been assigned as like part of their group. So if I'm this Joshua Colvin, I would log in and I would only see secrets in commits I've made, or maybe that my team lead assigned to me. They don't have a need to know all the other stuff, and they don't need all that additional noise. So the idea is the developer gets a notification that the secret was found in their commit. These are secrets that are still internal, but they're in the shared remote repositories or remote information sharing sources. So we consider that still to be a security incident because it's visible to everyone. So some cleanup needs to be done here. So if I'm Joshua Colvin, I can go and check and say, oh yeah, okay, crap, I did leak that. I realized what happened here. By default, we have obfuscation for the secrets that was detected. You can turn that off, but what we're seeing here is just some dots to provide a little bit of additional confidentiality. But what's key here is this is sort of the development collaboration interface. So the first thing I would look at is all the different occurrences. We find that when a secret's leaked once, it typically is leaked multiple times in multiple files, multiple repositories, often multiple developers. And that last piece is really critical. So if you think about development teams that are maybe using the same secret, but for different projects, if I'm Joshua Colvin and I just log in and I go, oh yeah, I leaked this secret, I have to rotate it. Well, Harry's app is suddenly going to break and he's going to have no clue why. He's going to reach out to ops, who Joshua already just reached out to, and see, okay, the secret stopped working, I need a new one. Maybe it's a different ops person who's not aware it's just rotated, so they might rotate it again. Joshua's app breaks. So there's a lot of coordination here that if you have just one individual doing things blindly, it's going to create a ton of additional coordination and work that nobody wants to deal with because it's not their job that they want to focus on a daily basis. So a key piece here is seeing all the different places the secret has been detected, so we can see what teams, repositories, projects, individuals are going to be impacted. We can coordinate all of that and be sure that everyone's aware of, what's going on and what's going to be done. So we'll avoid unplanned work there, avoid any kind of friction and pain points. And then what's also interesting is we have an indicator of something that's requiring a code fix. For us, secrets that are in these shared repos should be revoked and rotated. That's part of the fix. But then you also have the code fix piece, which is for us, if it's in the most recent version of code, especially if it's on a default or a main branch, we want to remove that secret and we want to clean up the code itself as well. So here in this piece, above and beyond the rotation, I can see, okay, well, there's this most recent version of code has that secret. So I need to go ahead and fix that. Once I fix that, I'm going to go and do the PR internally within GitHub or GitLab or whatever. So that file would actually shift here. And if I'm security, I'm overseeing this process. I know Josh was working on it. I can log in and check and be like, okay, he did the code fix. And right now they're waiting for that to be accepted. So we can see it's in that pending status. And then finally, once that's been accepted, and we can see the file would move to this last category, we'd see it's fixed. The most recent version of code no longer has that secret. So the code fix piece has been handled. And then we have the remediation or the rotation piece to worry about of revoking and rotating that secret potentially. So this is a bit of a sidetrack, but it's just to show that why it's so critical to involve developer teams into this process, because if it's just security doing this, or you have just a CSV file, there's all this additional context and processes, especially in an enterprise environment, that it's just not going to work. You're not going to get ahead of it. So the idea is developers themselves are going to be handling this process, perhaps dev team leads, security champions, different companies have different ways they organize it. But they're going to be handling this, and it transforms the process from something that security has to do and manually go through all of these to something that developers themselves are doing, and security is simply overseeing and supervising. And then, like I mentioned before, I don't have anything set up to show you for that today. But the prevention piece is key. So all these incidents are things in the shared repos or in the dev collaboration environments. But we have the scanning on the local machine that if I catch a secret in a file when I save it in my VS Code, for example, no incidents created here. No one needs to be aware. There's no other coordination needs to be done. But I will get the alert from GitGuardian, who has that integration locally, saying, hey, there's a secret on this file. You need to be sure that you go ahead and clean that up. So the idea is having both this dashboard piece and then the local piece to prevent. So very, very quick key points demo. I don't know, Lynn, any other things you want to call out there in terms of the main value that our clients get from us?
No, I think you did a great job giving that high level. I would say that if anyone wants to do a deeper technical dive, like we're happy to do a separate one-on-one session with any of your engineering teams to go in further and deeper one-on-one with you. So let us know if that's of interest to you, because I mean we could easily take a full hour just getting into the tools and into separate or unique use cases. So happy to do that with you. This is just to give a high level context and overview and highlight really how GitGuardian is uniquely positioned to help customers solve their secret sprawl challenges and overall reduce their risk.
So this is about where I think we'll start to hand it over to Lynn for the partnership and engagement side of things. But what's really interesting here and where we've had a ton of success working with various partners and supporting companies is if you think back to that public dashboard that I showed you earlier, we can generate a quick audit report for any given company or organization with their email domains. It takes a few minutes and we simply put that information in, create this audit. You can see a dummy template here of just high-level information about how many developers they have committing publicly, how many secrets have been leaked by those developers, and how many of those developers are responsible for the secrets that were leaked. The overall pattern of how many secrets are refining amidst all of their code. So this is something that we can do happily for free for any of your clients that you're supporting. Do a quick audit assessment of their exposure on public GitHub. That lets us identify if potentially there's something at risk out there. We'll also take a look at specific secrets we find and flag anything that seems like it could be potentially high impact. So that gives an idea of the public side. And then also typically what we see internally is about 4 to 5 times as many secrets as we find publicly. It's a rough average number. But it's also a useful proxy to see, hey, maybe this one client of mine actually has a pretty significant amount of developers that are committing code publicly, and they have a lot of secrets, and it's actually above GitGuardian's benchmark for a company of that size in that sector. We should probably have a look to see how we can help them better tighten up that perimeter and get ahead of this issue.
Yeah, I love an assessment-led sale, right? And so that's basically what this is. You as the trusted advisor to your clients are, much better positioned to offer this and help them identify some risk that they might not have previously been aware of, and will happily walk through the findings with you, or get on a call with your client after we've given them this report. So I know a lot of organizations say, hey, we'll do a free assessment for you. And what that really means is they're asking your customer to sit and do a mini POC and take time out of their day jobs and other projects that they've got going on and commit to spending time with the vendor. That's not the case with our report. It requires no interaction from your client to benefit from these results. So that's something that we can coordinate with you and work on for you and immediately add value. Most times when they see the results from this, it's an immediate, highly engaged response. So know that that's a great way for you to add value to your clients. It's also a nice way to prospect into maybe some of those organizations where you want to get wider and deeper and more strategic with. So I'll talk about the partner program now because we're almost out of time, but do take advantage of that free assessment. All right, so This is my part. I'm super excited about our partner program. Also, it's super simple, right? So I think about partnership as a three-legged stool. And most importantly, you and your customers need to know that they can trust the tech. GitGuardian is hands down the leader in what we do with secrets, and we partner really well in the ecosystem to make the most of limited resources within your customer's organization to try to get their arms around the whole secret sprawl scenario. So customers love us. We have an exceptionally high tech win rate. We have an extremely high renewal retention rate, and most organizations who land with us grow and expand with us as well. So if we haven't proven to you today that you can trust the tech, that we'll happy to do another session to get deeper in you. But I've been working in this security space for a long time, and I haven't, this is the first time I've really worked with a company like GitGuardian where the love of our product and the strength of the product is really shines. So the best thing now is let's enable the partner ecosystem to help us out there. So my philosophy is keep it simple. So we've got a super simple program. Hopefully this message was, simple for you to understand, and we'll continue to make easy training available to you. Our reps are comp neutral, so they are incented to work with partners in building out their territories. So the margins on the slide here are depending on the role that you're helping us with in this deal. And it's not just the margin, but it's protection for you as well. So if you're registered on the deal at any one of these levels and another partner comes in and asks for a quote, we won't give them a partner discount. So we highly, highly, highly want to work with partners who are going to help us build our territories together. And we are willing to provide additional margin and protection based on the role you play. So obviously, if you help us get meetings and introduce us into accounts, that's partner originated and it's the most lucrative. We want to co-sell with you. If we source it, we'll work with you and continue to give you that protection. And given that we've just launched our partner program, we might have some opportunities that are already past POV, and we want to work with you there too. And so that's why we've got the program the way that is laid out here. Did I mention that our reps are comp neutral? That means any deal that they work with you on, it's not going to cost them anything. So we're really, really partner channel first now that we've launched our program here in EMEA. A little bit of like, hey, what's in it for me? Am I really going to make money? Our average selling price in commercial, which we classify as someone who has less than 2,000 devs, is usually around 50 to 75K in ARR. And we're seeing more and more organizations do multi-year deals with us. And in the enterprise space that we consider over 2,000 devs, yeah, 250 is probably on the low side. I think that I'm seeing anywhere between 250, 350, even 500 to start with in ARR. And part of our program also, in addition to our reps being comp neutral, I don't know if I mentioned that, you also have renewal incumbency protection on these deals as well. So I want you to make money. I want you to know it's profitable. I want you to know that we have your back and we have your customers' back in protecting their environment. And I think that might be our last slide. Oh, yeah. So here's our email address. Reach out to us. If you're interested in partnering with us, reach out to your Nuaware partner manager. We'll get you loaded into our partner program.
Was that everything then?
That's it.
And I just want to double check. So they're comp neutral. That's what I heard. Yeah.
I think, yeah.
I think they are. Okay. Definitely heard that. Right. I think we'll still take a few questions. I know that we might go a little bit over, but I think there was two questions that definitely came up that I wanted to address.
Sure.
Casper, there was a couple questions that you asked. One of them I've answered already. I will also share the slides with you. I think that's exactly what you need. So one from Casper, and it's a two-parter, but I think, Daniel, the second part that you answered mainly during your demo, but I thought you might want to touch on it. How often do you see customers struggling with credential leaks in their repositories? So that's part A. Part B is, and how do they typically help? How do they typically handle remediation?
Mhm. I don't think I've yet found a company that was not struggling with credentials leaks. For me, it's really a question of degree and of severity rather than if they are or not. And it's also worth mentioning that it's not just their repositories. For the public side, we actually find 70% of secrets in developers' personal repos, 70% of company secrets, that is, in their personal repos outside of official repositories. So that's another completely different struggle. Um, in terms of the remediation, it really is typically something that's led by security. You'll have some member of the security team that's doing the follow-up on these, as well as the, 200 or 300 other hair fires that individual has to put out on a given day. So this is where that traditional bottleneck that I mentioned comes in, where you have a handful of security professionals trying to do this at scale for hundreds of devs who are introducing thousands of secrets in addition to everything else. And it's really that remediation process that's typically in place that is the key, blocker that we help companies eliminate.
Yeah, and then so one, I think so. Obviously, with Nuaware, we've got an array of like DevOps products. One of them is obviously HashiCorp that we work with quite closely. So obviously, I think there's one or two HashiCorp partners here today. I think you touched on it, Daniel, but I just want to make sure we reiterate that. So one of the questions that I've had is, some of my customers use Vault already. What's the difference between Vault and GitGuardian?
So we are two ends of the same process where Vault is them managing secrets, provisioning them, being able to let developers share them securely. We're catching where Vault's not being used correctly. So developers are very clever individuals and they find extremely ingenious ways of bypassing guardrails whenever they're set up and bypassing standard processes because it makes their lives easier. It's never malicious. But it's important to have those guardrails in place to catch the edge cases where their standard means provided by Vault are not being followed because otherwise it's great to have Vault, but if no one's using it, what's really being secured at the end of the day?
Yeah, 100%. I think that was more or less it for the questions. David, Lynn, thank you so much for joining us today. I really hope everybody's enjoyed it and learned more about GitGuardian. So, if any of you are curious to learn more about GitGuardian, how you can start speaking to your customers about it, and obviously also showing them some of those reports that Lynn touched on, please do reach out to any of your Nuaware representatives, either your ones in countries. Alternatively, you can reach out directly to me. So I'm the solutions leader here for Nuaware. Kurt, Kurt, at nuaware.com. I'm more than happy to take those emails directly. And thank you so much, Lynn and Daniel. Really insightful discussion, and I hope you enjoyed coming on today as well.
Thank you. I've been very excited for this partnership and super excited to be able to launch this program in EMEA.